Now let's take a quick look at metals and non-metals. So metals are all on the left side of the table. So everything on the left of this staircase is a metal, and everything on the right side of this staircase is a non-metal. So metals form positive ions when they react. So what are ions? Ions are when atoms receive charges, right? Watch my video on ions if you didn't do so already. So ions can either be formed when an atom gains a positive charge or a negative charge. A positive charge is gained when you have more protons than electrons, because protons are positively charged, right? So when an atom loses electrons, a positive charge is gained because you have fewer negative electrons and more positive protons. You can also gain a negative charge when there are more electrons than protons, because electrons are negatively charged, right? So when an atom receives electrons, it will become a negative ion because it has more negative electrons than positive protons. And why do atoms form ions? They form ions because atoms want to have a full outer shell of electrons because they want to be stable and unreactive. Then why do metals form positive ions then? Metals form positive ions because we don't really need to know about these metals over here. We really focus on these metals, group 1 and group 2 metals. This is what you really need to focus on for your GCSEs. So these two metals, group 1 and group 2, right? This tells us that there's 1 electron in the outermost shell and 2 electrons in the outermost shell. So it's either going to have 1 out of 8 electrons or 2 out of its 8 electrons, with an exception of lithium, where it has, lithium also has 1 out of 8 electrons. So all these elements in groups 1 or 2 have either 1 electron or 2 electrons in their outermost shell. So what's going to be easier for it to do? Is it easier for it to get rid of either 1 or 2 electrons, or is it easier to receive 6 or 7 electrons? It's a much less energy intensive process to just get rid of 1 or 2 electrons than receive 6 and 7 new electrons, right? That's why these prefer to just get rid of these 2 or 1 outermost electrons, because that's less energy intensive. And when they do get rid of these electrons, they become a positive ion, because when you lose your electrons, you're going to become positively charged. So that's why they lose ions. Now, on the other hand, for non-metals are, they usually, so these are the minor exception, but usually they have over 5 electrons, 5, 6, and 7. You're not going to really get asked about group 3 and 4 atoms in your exams, but so you just focus on 5, 6, and 7. So groups 5, 6, and 7 have 5 electrons, 6 electrons, 7 electrons in their outermost shell. So what's going to be easier? To get rid of 5, 6, or 7 electrons, or to just receive 3, 2, or 1 electrons. It's much easier to just receive a fewer number of electrons than to get rid of more electrons, right? So that's why these non-metals prefer to just get rid of their to receive new electrons, because it's much less energy intensive. So nitrogen will become a negative ion because it receives 3 new electrons for a full outer shell. Oxygen will become a positive ion. Oxygen will become a negative ion because it receives 2 new electrons for its outermost shell. Fluorine will become a negative ion too because it receives 1 electron for a full outer shell. So all the non-metals have negative charges, negative ions when they react because they receive electrons, and all metals have positive charges because they get rid of their electrons when they react. And metals tend to become more reactive as you go down the table. So if you think about this, it makes sense. Why would metals, so by metals I mean these group 1 and group 2 elements, they get more reactive as you go down the table. Now by reactive, I just mean the atom is more likely to react or bond with other atoms, like chemically react with other atoms. It's not like react or just get mad at other atoms. It's not the verb. It's just more likely to, join or bond or chemically bond with other atoms in order to have a full outer shell of electrons. So metals are more likely to become more reactive, so they tend to become more reactive as you go down the group. Why would that be? Just think about this, right? It's always better to just understand it than to memorize it. So lithium has 1 electron in its outermost shell. Francium also has 1 electron. If you calculate it, you will find out that francium has 1 electron in its outermost shell. Now, how electrons stay with the atom? So at the center of it, we have the nucleus, right? And in the nucleus, we have positive protons and neutrons. Now, the protons are what pulls in the electrons together. And remember, these electrons orbit the nucleus in what are called shells, right? So francium with 87 electrons is going to have a ton of shells, right? It's going to have like over 5 shells, right? So as the shells get further and further away, the electron here, so it's going to have one electron in its outermost shell, it's going to be less attracted, less pulled in. It's not going to be pulled in as strongly as lithium with just 2 shells, right? It's very close. But with 6 or 7 or a ton of shells, it's going to be weaker, right? The pulling force from the nucleus and the proton pulling it, it's going to be much weaker than lithium at the start of the table, at the start of the group, right? So as you go down, the number of electrons increase. That's a trend you'll see everywhere. You see, 87, 88 compared to 4 and 3. 5, 113. 9, 117. 2, 118. So as you go down the group, the number of electrons always increases. And as electrons increase, you need more shells to accommodate them, right? And the pulling force from the proton in the nucleus is going to get weaker and weaker as you get further and further away, right? That's just natural. If you have your AC on and you get further and further away from the AC, it's going to get hotter and hotter, right? That's just common sense, right? So it's going to be the same thing. The pulling force from the nucleus gets weaker and weaker as there are more electrons because there's more distance between the outermost electron and the nucleus. And what did I say about metals? Metals have either 1 or 2 electrons in their outermost shell, right? So they don't want new electrons, they want to get rid of electrons. So they will become more reactive as you go down because these metals want to get rid of the electrons, the outermost electron, right? And as you go down and down and down, the distance becomes greater and greater. So it's going to be easier and easier for this outermost electron to be gone, to just disappear, to go react with another atom. So that's why as you go down the group for metals, the atoms tend to become more and more reactive. It's pretty much the opposite for the nonmetals. Because nonmetals, they want to receive new electrons, right? So these electrons, they have 5, 6, or 7 shells in their outermost, 5, 6, or 7 electrons in their outermost shell. And these want to receive new electrons. But as you get further and further and further and further and further away from the nucleus, the pulling force of pulling in new electrons is going to get weaker and weaker and weaker, right? So that's why as you go down and down and down, the pulling force gets weaker, so it's less likely to react. So these nonmetals tend to become less reactive as you go down the table. So in summary, metals become more reactive as you go down the table because there's more shells, so it's easier to lose electrons because the pulling force is weaker as you go down and down and down. And they form positive ions because they lose electrons. So there's going to be more protons, so it means it's going to get weaker and weaker and weaker. I hope this explains a bit about metals and nonmetals. I'll see you guys in the next one.